And welcome back to Mega Mechatronics. This is part number 7. We've been waiting for this case study, and we're going to be using HB Tuner's VCM 3.6, and specifically the E78 ECU, the engine controller, for 2011 to 15 Sonic or Cruze with the LUV 1.4 turbo. And there was some delays on the way. I have some issues with the turbo, and I had a small hiccup. I bricked the ECU. It's totally my fault. So I'm out on Woodward. I pull over. It's actually pretty late at night, and I shut the vehicle off, but the whole dashboard and power's still on because I didn't open the door yet. So I make some touch-ups to the calibration. I begin writing the calibration, and I realize I left the key off. So I keyed on, and boom, it killed the ECU. So what I think happened when I keyed on, it dropped the CAN bus and power while it was erasing some things, so that totally corrupted the ECU. Again, it's totally my fault, totally preventable. So lesson learned here is to do a mental checklist every time you hit that right button, or rather, just before you hit that right button, make sure you go through the mental checklist of key is on, USB is plugged in, and you are prepared to sit there for the whole flash without interrupting it. Do not open the door, do not hit buttons. Make sure your laptop and equipment is in a secure location where it's not going to slip and fall onto your floor and have something like that happen. So those are my recommendations for preventing this very expensive mistake. Okay, the first thing we're going to do is hook up the HP Tuners module, and we're going to communicate with the vehicle through the OBD2 port. The OBD2 port is found on every vehicle. It's a diagnostic standard, and you can see here I'm trying to fish it through with this temporary type of install. So I went through the dash here, and I'll just unclip the factory port here. That's the location on a Cruze, but you typically find that under the dash somewhere. So I'll tuck it up in there and zip tie this. And mainly we want to get on to the communication bus, the CAN network. So we'll fish some more wires, and here I'm going to hook up the wideband input, the lambda sensor. So I have an Innovate LC2 controller with the wideband sensor, and this is the 0 to 5 analog output from the LC2 wideband controller. And here I'm hooking up the ground. You always want a common ground with any signals, any sensor. So the HB Tuner's ground needs to be connected to the sensor ground, physically connected at some point. You always need a common ground with any type of sensor like that. And we'll plug in the USB to USB, so that will go directly into your computer right here. And we can just hit record with the key on, and we are communicating. Well, for the Cruze, I'm going to look for something that supports GM, so you can look into something like EFI Live. HB Tuners is what we're going to use in this. So here's the supported vehicle list. So they cover most of the domestics, and these are license-based or credit-based. So EFI Live is going to have something similar. So here, I think credits are maybe around $50 USD with HB Tuners, and I had to use 2 credits. I think you get 8 credits with the package when you get the HB Tuners package. So maybe look into that. So here's a little example of me licensing after I brick the ECU. So we have this warning. You can see how many credits you have. So I'm going to do just a single vehicle with 2 credits, and we'll hit OK. And they give us an "Are you sure?" and then we will commit these 2 credits to allow us to edit the calibration. So we'll go ahead and save this, and we're done. The engine tuning loop is essential for recalibrating your car, and the VCM scanner is a huge part of this. You're going to need it to record your inputs, analyze the results, and then to calibrate the outputs, we'll use the editor. And now let's look at adding some channels. So you go over to the channel section and you can see this is RPM, boost, all those signals that you want to see. So you hit the gear plus to add a channel, and it brings up your actual ECM ECU and its capabilities. So typically we want to pick the green box because those are broadcasts anyways instead of requesting a broadcast. You can see I had them set up a little incorrectly right there, but you could see just start going through here and finding what you need or what is recommended. So pedal position, throttle position, airflow here, it's a main one here, mass airflow, your mass airflow sensor, your intake temps, manifold pressures, boost, of course, we like boost. So you can see there's a lot of different signals that are available from the factory. So total knock retard, very important. And there's a fuel control module. We don't have access to that. And so let's throw a signal in there just to show. So we'll just pick this fan. So you double click and we'll go back to the channel list, and there it is. So now if that is available with your calibration and vehicle, it will show a value under the value column, and you can just right click and remove those. And I always recommend saving, continually save just in case anything happens, so to avoid any problems. So here, let's take a look at adding a wideband sensor. So we go back to our channel, Gear Plus, and we need to add the MPVI Pro input. So I put the wideband sensor wire into number 1 there. So I double clicked on that. You see that at the top. Now we need to transform this channel. So this is really easy. We're going to find the LC2 and choose that as the equivalence ratio. So we'll get some lambda numbers. And then we can go in here, and you'll actually, for the parameter, when you add that to the scanner, you'll go in here and under transforms, we'll pick that LC2, the same one that we transformed to, the same channel there. Double click on that, and then we're all set. Now let's look at making some custom PIDs or custom channels with some math. So we'll go into Tools, Math, and here's an example. You can pick one of the unused ones or overwrite. So we name this one Boost, and you can see 11 is the map sensor .psi, so it's going to output PSI instead of KPA, and I did minus 14.37 because I am at an altitude of around about 650 feet here in the Big Mitten, so I'm going to use 14.37. And then of course you can add any available channel or parameter, so we'll just insert from our list. So you want to make sure you've added that channel like we showed before, and you can pick it there and it'll bring it down. You can see unit ID is 11, that's manifold pressure, and then you can Google the syntax and things like that. So now we're going to check out the meat of this. So the gauges, we'll build some of these, the graphs or oscilloscope, and then the chart, histogram, graph. The names are all confusing. So let's look at the gauges. Okay, let's take a look at building our gauges. So there's two different styles, a bar or a circle or ellipse rather. So go right click, gauges layout. Brings you into the editor, and you can see on the left side we have a lot of things going on, a lot of gauges. So quick look at the knock. We're 0 to 10. 0 is counted, so that's why there's 11 ticks. And we see ranges for the warning and location and size. But let's take a look at the boost. So we want to choose a parameter, so you can pick any parameter or any channel that you added. We're going to pick this custom boost that we made. We'll choose the units, and then we'll choose decimal places. And again, here's our ticks personal preference with this vehicle. I chose 0 to 25. And since 0 is counted, we want to put 26 in there. But you'll see when you're playing around, if things are looking weird, that's probably part of your problem. So the ranges are nice. Level 3 is red. And, well, over here, we're going to play around with moving this around. So for every single bar and ellipse in here, I set the left top width and height to place them everywhere. And the width does change the font size as well for the gauge. So that's something to consider. I like the really tall bars just for visual area, so you can see it. And here's that red, so the gauge will turn red when it enters that 20 to 25 because level 3 is red, so it'll color the gauge red. It's very useful. I don't really use level 2 or 1. So we'll switch out here and let's take a look at the ellipse real quick. I think we'll use speed as an example here. So you can see speed, the bottom circle there. And we chose that as an ellipse. And so let's play with the arc start, arc sweep. So the arc start is the starting point for that arc. So the position of that 0. And then the 270 is the amount of sweep. So from 0 to 160, that's 270 degrees. So it's good starting point, 135 and 270 for that. And let's take a look here. So draw min max, you see the ghosted needle. We'll show you your max whatever parameter. And again, simple location and size. So you change this percentage, it moves it around, sort of guess and check. But again, I did that for every single gauge here. So it's a little bit of time investment, but once you're done, you're all set, and you can just change stuff around, change the parameter. So this is the gauge layout. Okay, let's check out the chart versus time, or the oscilloscope. Makes more sense, the scope. So you could see the values changing on the very left side, the ranges of the graph, or the scope, on the right side. So let's go into the chart editor, chart layout, and you can see each section is called a group. So a section of variables there. So RPM, speed, throttle, math, boost, boost solenoid is in group 1 on that top block. So to add, you just hit the plus symbol. You can see I have existing ones here. So what you want to do is select our parameter, very similar to the gauges. And go in here and choose it. So example again, we go to our transforms, oxygen sensors, and the same one that we transform to that input signal. And colors, so this is fairly self-explanatory. So you always want to save your stuff when you're done editing. There could be, if you crash HP tuners, you're going to lose your setup. So again, you see our ranges on the very right side. And that's about it. Okay, now let's take a look at the graph tab. Take a look at the histogram, the chart here. I know the names are confusing. So what this does is takes a single variable, single parameter, and averages it into a cell, or puts it in a cell to get max and min, and things like that. So this is actually pretty useful because these align, these match up with your editor for tuning, and it's a quick way. Instead of looking through the scope manually, here's a quick overview of the health status. So you go right click into the layout, and we'll choose knock here and try to set it up. So you see the top selection there, that top parameter is what gets put into the cell. So like the other gauges and stuff like that, select your parameter and that's what gets filled into the cell. And here's some shading, very useful for seeing problem areas. So the higher the value, the more red it is, and it just stays white for no knock action. Now here it might be confusing. Here's our column axis. So we want to choose RPM for the column, and then here we go for our rows. We choose cylinder air mass. And these are very intentional because this matches your editor, and you see these values should really match up. You don't have to, but it is highly recommended you make those the same. So let's go into our spark table because the knock will be related to our timing. So you see the row, the RPM values match, and they're not linear. They skip areas. It's a little higher resolution around idle. So what you can do if you have Excel is you right click and you copy with the axis, you paste that into Excel, and then you can copy those values, the RPM steps. Same with the spark air mass or the air mass values. So you click the axis, dump that into Excel, then highlight just the air mass values and paste that into your scanner setup. So these numbers here, or you can type them in manually. I've typed them in manually just to get it done because this, my little tablet doesn't have Excel, so I had to do it all manually. So we can take a look at this two-dimensional graph here a little easier. So we'll look at the MAF. The wideband, I need a new wideband, so I was getting incorrect values there, 0.5. So we'll look at the long-term fuel trim setup here for MAF. Go back into your graph layouts. We'll choose MAF. So we want long-term fuel trims to be populated in the cells. So you choose your parameter, and that's what gets in the cell. So here, the richer it is, the greener it goes, and the leaner it is, the redder, more red. So here we're going to choose our mass airflow, and again, these values line up exactly with the editor. You don't have to have the same values; it'll still work. But you're not going to be able to do any copy-paste type of tuning or adjustments to the calibration using a simple copy-paste. So you can see the cells line up, the cell values in the actual editor. We're here in the editor, and you can see, I'll just do a quick way, hold shift and then click down here. And then you copy with axis, dump that into Excel, and then just grab the airflow frequency and then paste that into here. Or again, you might have to just manually type them in, put a space, 150, space 300, etc. And then there's other functions there, but that's basically it for this setup. Okay, so that concludes part number 7. Thanks for watching. It did get pretty detailed, but that's intentional because there wasn't a resource like this when I was learning all of this, and I put tens of hours into researching these details, and there's not too much, there's not really a comprehensive spot that you can go to get a lot of information. So that's why I made these Tuning 101 series, and it's not a 201, it's not a 301, it's a 101. So we need to really get down to the basics and the foundations, and the scanner setup is very important, and that's why we went into such detail there. And you got 90%, the last 10% you may have to use the Googles there, use some forum support, especially for non-HP tuner calibration software, because I don't have EFI Live to show you. I have HP Tuners, which is actually a pretty popular piece of software. So I did mention an issue with the turbocharger at the beginning of the video. So here we have the 1.4 turbo manifold integrated with the turbine housing. This thing's really cute, and you wonder why I'm not getting very high peak power numbers. This is the restriction. So maybe, well, inevitably I'll probably chop this off, put a flange on here, put a bigger turbo, but that's several projects down the road. So the issue I was having is actually a common problem with the 1.4 turbochargers. So try to identify this crack here. So basically, starting at my finger, you'll see into the wastegate flapper a crack, small crack, and that's causing a boost leak, and then I'm losing boost at high RPM. So in very hot weather, I'm losing 4 to 5 psi, between 5 and 6,000 RPM. With the temperature, ambient temperatures dropping, I'm losing maybe 2 or 3 psi. We can take a look at that. I'll overlay that, and you'll see the boost is dropping off. And what's telling me that the crack is causing the issue is that the boost solenoid is maxing out. In hot weather, it's going to 100, and the boost is dropping. So that tells me that something is leaking the boost off. Apparently people are consistently getting 21, 22 psi. So I assume they don't have a crack in their turbocharger. But thanks for sticking around. Like and subscribe, and we'll be getting into part number 8 with this case study, and we'll get in deep with the editor and everything I changed to max out this vehicle, max out the turbo with all the bolt-ons that we have. So thanks for sticking around. Check out the next video. Thanks.